Hello everyone. Now today let us see the chemistry of rare gas compounds, or we say the inert gases or the noble gases. Now we will cover in this the introduction portion, occurrence of the noble gases and the history of discovery of these noble gases. Other topics are compounds of the inert gases, preparation, structure and the properties of the various fluorides and oxides of the rare gases, that is xenons, oxides of xenon and krypton fluoride, and the applications or uses of the noble gases. Today we will take the introductory portion, occurrence and the history of discovery of the noble gases. First thing is, we know that the noble gas are in the group 0 or group 18 in the periodic table, which includes the 6 elements that occur naturally. These 6 elements are helium, neon, argon, krypton, xenon and radon. The general electronic configuration, if we see, it is Ns2Np6. We also call these as group 8 elements because its outermost shell has total 8 electrons and it is completely filled, and hence it does not have the tendency to undergo any of the chemical reactions, and that is the reason why we call this gases as inert gases, because they are highly stable. But the recent research have shown that these noble gases, or we say the inert gases, which we used to call this, they enter into the chemical reactions under specific conditions, giving the formation of a few chemical compounds. So now instead of inert word, we are using noble gases for these elements. Scientists have discovered that since the heavier noble gases atoms are held together less strongly by the electromagnetic force than those of the lighter noble gases. That means if we move on from helium to radon, so that means helium, neon, argon, krypton and xenon. So helium is the lighter one, then the heavier ones comes. That means helium, neon are the lighter ones, then argon, krypton, xenon, radon are heavier compared to the earlier ones. So we find that air contains about 1% of the inert gases except radon, because radon is obtained by the disintegration of the radioactive element like radium. So out of these 1%, the constituent of these gases are as given: 0.93% of argon, 0.01 to 0.02% helium, 0.00086 neon, 1.42 into 10 to the power minus 5 krypton and 2.5 into 10 raised to minus 6% xenon. These all are by weight in the air, and because of this reason, that is, these noble gases occur only as a minor constituents in the atmosphere, we call these as rare gases also. Now we find that the maximum amount of the inert gas which is found in air is argon, and if we see the maximum amount of inert gas found in the universe is helium after hydrogen. Hydrogen is in the maximum amount. After hydrogen, helium is the noble gas which is found in the universe in maximum proportion, maximum amount. If we see the electronic configuration, helium atomic number 2, it is an exception to the general configuration we have given Ns2Np6. After that, neon atomic number 10, so it is completely filled, 1s2 2s2 2p6. Then after argon atomic number 18, if we write further, after 10 neon is 1s2 2s2 2p6, then after 3s2 3p6. Then stable configuration of 18 we can take, that is argon. So for krypton atomic number 36, we have 3d10 4s2 4p6. This whole configuration of krypton we can take as a stable configuration of krypton. So for xenon atomic number 54, we write krypton till here 1s2 2s2 2p6 3s2 3p6 3d10 4s2 4p6. After that it enters into 4d10 5s2 5p6. So outermost shell is ns2np6 except the helium. And finally radon, that is atomic number is 86. So we have outermost shell 6s2 6p6 and penultimate shell It is of 4F14 and 5D10. Now let us see the history of discovery of the noble gases, how this noble gas were discovered. Earlier in 1785, a scientist named Cavendish performed experiments to determine the composition of the air. He passed repeated electric sparks in the mixture of the dry air freed from CO2, carbon dioxide, with the excess of oxygen. His idea was to cause complete conversion of the nitrogen present in the air into nitrogen dioxide by the reaction given. That is, nitrogen in the air, we pass the dry air and electric spark and it gets converted into nitrogen dioxide. He absorbed the resulting nitrogen dioxide and unused oxygen in potassium pentasulfide K2S5. So there should not be any residue left. But to his surprise, what he observed is 1/20th part of the original volume of the air remained undissolved, which he could not identify what was that. So that was later on characterized and isolated after 100 years, and it was characterized and isolated as identified as argon. After that, in 1868, Lockyer observed a bright yellow line in the spectrum of sun's photosphere, which was taken during the eclipse of the sun. And after a long study on that, it was stated that the line was of a new element. And this new element was named helium from the Greek word helios, which means the sun. Okay. Further, in 1894, Rayleigh, he found out that the density of nitrogen that is isolated from the atmosphere is 0.47% higher than the nitrogen prepared by the thermal decomposition of ammonium nitrite. So he worked continuously on that in collaboration with Ramsay, and they both continued their work for several years, during which they carefully and repeatedly distilled the liquefied gas, and ultimately at the end they found out a new inert gas named it argon. In Greek, argos means inert or idle. Further, Ramsay and Travers suspected that argon, which was found out, is consisting of the number of similar constituent gases, and spectroscopic evidence also proved that. So they continued their work on the argon, and by repeated fractional distillation of the liquid air, they obtained the first fraction, that was a new fraction, which they call it as a neon, in 1898. Further, they took larger volumes of the liquefied gas, and on refractionating the various fractions, they isolated another element which they called as Krypton, meaning hidden. So from argon, which was found out first, from that a new element was found that was named as neon, and in that, again fractionating that, they found out again a new hidden compound that was named as Krypton. And shortly afterwards, they were successful in isolating another new element which they call it as a Xenon, meaning stranger. The last member, Radon, was identified by Dorn in 1902 amongst the radioactive disintegration of radium, thorium and actinium. These all noble gases except the radon are available in the atmospheric air. Radon is the only one noble gas which is radioactive element, and it is obtained by the disintegration of radium, which is ongoing spontaneously in the nature. So we have a radium, disintegration of that, it gives radon 86222 and helium.